Yeah, I'm very happy to be able to present our initial results of our Circus of Knowledge research project to you today. And we have looked at effects of integrating art into the classroom on motivational pupil characteristics. In the beginning, I will shortly introduce the project. The Circus of Knowledge project is part of the Sparkling Science 2.0 funding line of the OEAD Center for Cities and Science. It is financed by the Austrian Ministry of Education, Science and Research, and the project runs from September 2022 to August 25. So we're currently at the very middle of our research. And what are we doing? As the title suggests, we're looking at the integration of art into mainstream lessons and investigating changes in motivational pupil characteristics. And on the one hand, we have active artistic research in which scientific topics are explored in regular lessons with the help of art. And on the other hand, we have passive accompanying scientific research, and this is my main part. At the artistic research, we have mentor teams consisting of an artist, a student teacher from the JKU, and a scientist. And those prepare workshops on curriculum topics from the Austrian STEM curricula. The exact topics are discussed with the respective class teachers in advance, so in the holiday seasons, in the summer, and then carried out directly in the regular lessons from the artists and the student teacher. The workshops last around 7 to 9 weeks and replace the regular STEM subject lessons during this time. So, for example, the artist comes to physics lessons for 7 weeks and deals with the topic of atoms and their bonds, maybe. And it is really important for us that the workshops are organized in such a way that the teacher does not have to do any follow-up work after the workshop, so that the curricular topping is really done with those workshops from the artists. We have artists from many different genres, so we have dancers, musicians, theater, pedagogic, so a really broad spectrum. And yeah, the scientific research serves to investigate the changes in motivational aspects of the pupils. After all, the pupils should not just be entertained, but should actually record an increase in learning. Maybe it is on a personal or at the performance level. And we try to obtain longitudinal data, so the data is collected at different times over the whole period of 3 years. On the one hand, we work with quantitative questionnaire studies, with full service being conducted at 4 points in time. So before the first project, T1, then is cycle 1 of the workshops, then we do another one, T2, and so on. So it's between every cycle and then after the last cycle. Today we will look at the results from the time points T1 and T2, so the cycle 1. On the other hand, we have quantitative results. On the other hand, we have the qualitative data. As we have many pupils with a very poor knowledge of German, we want to make sure that our research really picks up on everyone. And this is done by observation sheets in the workshops. Those are done by the teacher students who are in the classroom. We have reflection sheets after the workshop. Those are written by the artists. And at T3 and T4, we have done guided interviews with the teachers, the artists, the teacher students, and the groups of pupils. So a very broad spectrum of those participants. all in all, we have a total of 245 pupils who took part directly in the project. So 242 get those artistically workshops. And in order to be able to carry out more complex analysis, we have a control group of almost the same size. This consists of the parallel classes and other school classes of the same age in the quantitative survey, and 9 teachers, 6 artists, and 245, so all the project group pupils in the qualitative survey. Yeah, the pupils are from 9 different schools from Linz in Upper Austria. So the from STEM to STEAM educational research is not that big in the German-speaking area. So it is the very first beginning in this. So we have really just schools in our area, and we have middle schools and gymnasiums. So yeah, the very broad spectrum, and they are all in the secondary age group, so all around 12 years. In our first data analysis, we dealt with the research questions: can art-integrated lessons arouse enthusiasm and interest in science, and does this apply in particular to groups of pupils who are usually characterized by a lower affinity for science, such as pupils with a lower educational background? We asked the jobs of the mother and the father and the first language, or the language they speak at most at home. So those are our hypotheses that we were tested. If art-integrated lessons can statistically significantly increase in interest in STEM subjects, the variable flow, the intrinsic motivation, and the self-efficacy expectations. Our questionnaire covered the construct STEM and art interest. So I am interested in math, nature, computers, and so on a scale from 1 to 5. So flow with time passes quickly when I'm working hard. This is from the science motivation questionnaire. Also the intrinsic regulation and self-efficacy. So those are tested items we used and just translated into German. Yeah, our first look was at the descriptive statistics. We are already seeing exciting changes that we did not accept. For both interests, the project group decreased and the control group increased. For flow, the value decreased for both groups, but much more so for the control group. And for self-efficacy and intrinsic regulation, the control group score increased more than of the project group. We then calculated the single indicator latent change score model, where art inventions were modeled as dummy-coded predictors, and we investigated whether the first language also has an influence on the change. We found that flow changed significantly in both groups, with language only having an impact on the control group. Flow decreased in the project group and increased in the control group. The same applies to intrinsic regulation. So those are clearly not the results we expected and what the literature suggests. And yeah, we of course thought about why this is the case, and have also found some explanations in the literature. At first, it is a new method of teaching. Students have to learn methods before the method itself can be used effectively. The students' interviews, which we already have done, also showed that they often did not perceive the workshops as lessons. In other words, the questions from the questionnaire were not answered specifically enough in relation to the workshops. So we're very, very thankful that we have done the qualitative research. And thanks to it, we were able to get a better overview. And as a result, we decided to take a closer look at these in the next step. because my first analysis of the qualitative data showed very clearly changes in self-efficacy from the students, so the pupils' sides, but also from the teachers, and a positive change, of course, in the classroom community. So, yeah, the integration of art into STEM lessons is justified and increasingly becoming the focus of the research. The qualitative insights are promising and give rise to hope for further quantitative results in the next project cycles. And yeah, we're also looking forward to the final evaluations, which will then take place, and we will analyze from T1 to T4. And yeah, we hope, and I've already done some analysis from the T3 data, and slowly we get in the right direction. So there are now results with more of those things that we wanted to show. But yeah, I think it is a long way to go, but the project is great, and all the students and teachers shows in the qualitative data that it is a good thing and we should keep up. And yeah, I guess that's the thing we do. Thank you very much for your attention, and we have some few minutes left for any questions.